Assalamualaikum. So today we're going to present about ventilator. Our group member Siti Hajar, me, and then Alisha Sawana, Nadia, and also Aisha Shakira. Okay, next. So the background of study about ventilator. Okay, so firstly about 5 until 15% of patients with COVID-19, which is coronavirus disease 19 infection, require intensive care, surveillance, and also ventilatory support. And then mechanical ventilation has routinely been employed to oxygenate seriously ill COVID-19 patients. Mortality during mechanical ventilation appears to be high. However, lung protective ventilation is mandatory. So that's why ventilator is lack nowadays. So the shortage of ventilator during COVID-19 crisis has focused popular attention on thermoforming mechanical breathing machine.
Okay, so let's move on to the problem statement. The problem statement here is first is high cost of manufacturing process and productions of medical ventilator. Okay, did you know that the intensive care unit represent one of the largest clinical cost centers in hospital, and mechanical ventilators accounts for a significant share of this cost, where the price of one ventilator are about between $25,000 to $15,000 USD. Next, the second problem statement is the manufacturing process of the mechanical ventilator requires a very long time period. Okay, usually which is the current productions of manufacturing ventilator required at least 8 months, because this ventilator needs to be tested, and then it's required a very meticulous work, so that it takes a very long time period. And then the last one of the last problem statement is the mechanical ventilator could not be shared by 2 patients at the same time. Current design of the mechanical ventilator can only be used for one patient only at the same time, where the sharing of the mechanical ventilator not be tempted, because it cannot be done safely with the current equipment of the mechanical ventilator right now.
Okay, so the objective of designing the ventilator is firstly, we want to design because of the shortage of ventilator. There are not enough ventilators to cope with the coronavirus. The second one is to meet the highest medical requirement in terms of functionality, reliability, and process stability for ventilator. Also, we want to design ventilator as well as understanding ventilator patient interaction, because the patient does not have to work as hard to breathe, so their respiratory muscle can rest. The fourth one is to protect the wearer from injury or help prevent wearer exposure to infection or illness. Because it helps the patient to get adequate oxygen and clears carbon dioxide. Also, it preserves a stable airway and prevents injury from expiration. The last one is to offer the best chance of ventilators. So next, the material that we use in designing ventilator is thermoplastic. Thermoplastic has many types, such as Solvay's medical grade Udel PSU, Viradel PESU, and Radel PPSU design. But the most But the soluble material is the most recommendation for ventilator component because Solvay has a unique selection of medical grade polymer. They have been and still used in surgical instruments, sterilization containers, a variety of medical support equipment. Solvay also have 100% oxygen compatibility. And Solvay has limited outgassing and leachable. So it also, the thermoplastic also has hard strength, durability, and impact strength. It also has a strong resistance to chemical cleaners and disinfectants. And it also transparent and opaque colors are available for this material. So it's a good material for designing the ventilator. Next.
Okay, so we proceed to the material processing. So for this thermosetting material, we will process it through thermoforming, which is a vacuum forming method. So firstly, the plastic sheet is heated and wrapped over a mold like the picture shown below. And then the mold is mounted in the machine and the heated sheet is located over the tool. The sheet is in the black color. And then we go to the next step, which is the vacuum forming method is applied to the sheet to remove the air between sheet and mold. And then lastly, the molding is then be cooled before we eject it from the mold by using reverse pressure. So that it means that we blow the air into the mold to eject the part. So the vacuum forming is used to transfer the heated sheet into contact with mold surface. And this thermoforming process, it covers all process which involve heat to shape polymers. And actually thermoforming under vacuum forming under thermoforming method has two forming process, which are vacuum forming and also pressure forming. But vacuum forming is the widely used method. Okay, next.
Let's move on to the design consideration. Okay, so for design consideration, one of the reasons why the current ventilator could not be support more than one person is due to the screen, which is due to the screen of the ventilator, where it was set up and can be only and can read only the data of one patient only, and it is semi-automatic ventilator. Semi-automatic ventilator is mean that the ventilator or the informations of the patient are needed to be inserted manually, and the required oxygens or the amounts of the volumes of the oxygens that need to be pumped on the patients are worse calculated or worse inserted manually, where this can causes a biotrauma to the patient, and it can causes the damage to the lung. The special of the fully automatic ventilator is the ventilator will automatically understand or reads our body where it have a sensor. It can sense the required oxygens of our body, and it can pump the exact amount or the correct amount of the oxygens that are required in our body. And then fully automatic ventilator also will automatically rechargeable for 7 hours inside the internal battery. And then we also have the internal compressor. Okay, internal compressor is a built-in air compress that uses room air to supply the existing oxygen sources or ventilate patients when the medical oxygen is unavailable. And then we also have the support arm storage. Just like we know, before this we only have a support arm, but it does not have a compartment or storage to keep this support arm. This is to prevent the attachment of contaminant on the surface of the support arm, where it can causes the contaminations to be occurred. It is the same concept as the ventilator breathing circuit storage. Ventilator breathing circuit on the current design does not have a special compartment or storage to keep this ventilator breathing circuit, where this can causes the contaminants such as particle, dust, fungus, bacteria, chemical or ions or metallic to be attached on the surface. Okay, next is the smart alarm. As we all know that the noise pollution in the ICU is a result of the mechanical ventilator alarm. However, in the vast majority of circumstances, the alarms are false. As a result, the staff are programmed to ignore the alarm that we call as the alarm fatigue. So that I suggested the new design of the mechanical ventilator are required to have this smart alarm where the high pressure alarm will does not need to sound every time pressure exceed the set level, and it can and it able to identify the patterns of the alarm. Okay. And then we have the oxygen reservoir. Oxygen reservoir enabling use with low flow oxygen sources like a concentrator or flow meter. Okay, next is the wheel. So the wheel of this ventilator are suggested to use the polyurethane wheel, where these polyurethane wheels are excellent for shock absorption in abusive industrial application, and it also have low rolling resistance, and then very high dynamic load capacity, and then suitable for high speed, and it can support 400 to 30 kg load capacity. So this is the back view of the mechanical ventilator design. So at the back view, which is this one for patient 2, this one for patient 1, and then the oxygen supply, and lastly the external battery. So the external battery is function as when there is no electrical supply or power supply, and also the internal battery that was automatically stored for 7 hours was also drained. We still can use this ventilator by using the external battery that designed in the mechanical ventilator.
Okay. For, for, for product benefit, so basically the benefit of this product is the first thing is it is easier to manufacture, and this is because it is manufactured by using the thermoforming process that takes shorter time to manufacture. And then this product is also uh, easier to handle or calibrate because it is a fully automated system where the medical staff just need to enter the data of the patient and the ventilator will calibrate. Other than that, it also requires shorter time to set up and start up, basically influenced by the fact that it is easier to calibrate. And then this ventilator also has more features that allow user to customize according to the individual patient's need. Because we can directly include the data of the patient, such as the body weight, the height of the patient. So the data will later on be integrated to come up with the fit requirement for the patient. And then this ventilator is also not too bulky in terms of the design, as it is portable, and also require low cost to manufacture. And this is influenced by the fact that we use thermoplastic material that is actually much more easier to fabricate. And then it also have a long lifespan and also low maintenance, because most of the components of these ventilator are easy to be obtained and affordable. And besides that, this ventilator is also easy to clean and sterilize. And then for our design of ventilator, we also, as Nadia mentioned earlier, we also have a special compartment for the ventilation tube. So the importance of having this special compartment is because it can protect the ventilation tube from being contaminated, and at the same time we can prevent cross contamination from occurring, especially during this COVID-19 outbreak. Okay, and last but not least is this ventilator can support up to two patients at one time, because based on the design, in one ventilator we provide two gas tank, and also in terms of the data, we also uh, set the ventilator to be able to keep data for more than one patient. Okay. So moving on to the next one is cost and performance. Okay, in terms of cost, generally, this our design of ventilator will require low processing cost, mainly because it uses thermoforming process, which is 30% cheaper when being compared to the capital expenditure needed to set up an injection molding plant. And other than that, it also uses thermoforming plastic, which provide designer with alternative to more expensive materials such as metals. Okay, in terms of performance, uh, it has a better gas delivery capabilities. And then, as mentioned earlier, it is fully automated, which makes it work more faster. And then it also proved to provide low tidal volume ventilation. So the importance of having low tidal volume ventilation is because it is safer for the patients, since it can protect patients from receiving excessive amount of pressure that can lead to any ventilator associated conditions such as acute lung injury. And last but not least is it also provide high positive expiratory pressure, the PEEP. So the PEEP is a pressure that is applied by the ventilator at the end of each breath of the patient. And then with this PEP, less pressure is needed to get the same volume of air into the lung, because the presence of the PEP will help to inflate the alveoli of the patient, which in turn will not require us to supply too much pressure to the patient, because the alveoli is already inflated. So this can help to reduce any lung injury or any incidents such as traumatic alveoli. So that's all from us. Thank you very much.